Agricultural technology is a branch of science focusing on the processing of agricultural resources using modern technology for the improvement of human welfare. To accomplish this, the Faculty of Agricultural Technology, Universitas Brawijaya, was officially established in 1998.
Faculty of Agricultural Technology is one of the largest faculties in the field of agricultural technology in East Java, Indonesia. With 3 departments and 11 study programs, we offer you a remarkable opportunity to feed the world and to help the community through food science and environmental-related technology and engineering. Faculty of Agricultural Technology is the first faculty in Brawijaya University in one of 14 faculty nationally that is selected to build zone of integrity. The zone is corruption-free and provides continuous excellent services. Being a well-known faculty in the field of agricultural technology at the international level and contributing the national development through the 3 pillars of higher education is our vision. We are encouraged to conduct research and development in agricultural technology field and create collaboration with other parties, enhance the progress of the world agro-industry. To achieve this, we provide best facilities for our students.
The Faculty of Agricultural Technology has 11 professors and 57 doctors. They have a great reputation due to their extraordinary achievements on the national and international levels. The far-reaching reputation of the Faculty of Agricultural Technology lecturers is evidenced by their frequent invites to speak and to offer their valuable input. They have been trusted as keynote speakers and consultants for both government and private institutions. They have been reviewers of nationally and internationally reputable journals, and they have also been keynote and invited speakers at national and international seminars and events. To grow the Faculty of Agricultural Technology's lecturers' knowledge, the faculty strongly supports research activities such as joint research and publications, international conferences, postdocs, and further study at the University of Nottingham, Sheffield University in the UK, University of Western Australia, and Kyoto University in Japan. To attract students, the Faculty of Agricultural Technology promotes all of their study programs at several other universities at the national and international level. Teaching and learning activities are optimized using various innovative learning methods. Through the use of the integration system Gapura Universitas Brawijaya, all information is easily accessible electronically by lecturers and students. To broaden students' international perspectives and give them international experiences, the Faculty of Agricultural Technology gives lectures in the form of a 3-in-1 program activities, a visiting professor program, international classes, double degrees, student exchange, distance learning, short course programs, international conferences, and joint research projects. To improve students' competency and insight into the application of their knowledge, the Faculty of Agricultural Technology routinely brings in guest lecturers from industry and provides training and certifications. We continue to develop a high standard for research and education facilities, as well as establish relationships with alumni, partners, and stakeholders. Our faculty and staff are also dedicated to bringing students a high-quality education by providing state-of-the-art teaching and research. Through talking about and encouraging student participation in research and in community service with their lecturers, the Faculty of Agricultural Technology helps to improve the critical thinking, teamwork, and communication skills of their students. Faculty of Agricultural Technology will always provide the best quality of education and commit to producing high-quality graduates. With our motto, "Do the best towards perfection," the Faculty of Agricultural Technology, Universitas Brawijaya, is ready to strengthen the agricultural technology of Indonesia.
Assalamualaikum Mbak Rizky.
Waalaikumsalam Pak Imam.
Mana Pak Rizky kabarnya?
Alhamdulillah, alhamdulillah.
Nah.
So, good afternoon, everybody. I hope you can all hear me fine. And firstly, my name is Rizky. I am the moderator for today's webinar. And thank you for joining us. I hope you all fine. And we're still expecting and waiting some more participants to join this webinar. And we expect this webinar to start at 12 p.m. So if you can just wait, that'll be great. Thank you. So, and also firstly, I would like to welcome Dr. Syakirin from Malaysia. Thank you for joining us, Dr. Syakirin. Looking forward to your speech today.
Thank you. Thank you, Mr. Rizky.
Thank you, Dr. Syakirin. So, hello everybody. It's 12 p.m. already, but I think we will wait for around 1 minute or 2 minutes or so to let some more participants coming in. And welcome to Professor Nizam, who've joined us from Malaysia. Thank you for joining us, Professor Nizam, and also hello and welcome to Mr. Christian, joining us from Mayura Group. Thank you for joining us, Mr. Christian. So, welcome, Dr. Arif from Universitas Brawijaya. Thank you for joining us.
Thank you, Pak Rizky.
Right, so it's 2 p.m. already, and we already have all of our 4 speakers joining us. So I think it's fine for us to start this webinar. Right, so good afternoon, everybody. I hope you are all fine and well. Firstly, my name is Rizky. I am the moderator of today's webinar. And welcome and thank you for joining this webinar, which is titled Innovation-Based Development and Engineering Systems in Agro-Industry, held by the Faculty of Agricultural Technology, Universitas Brawijaya. So today we will have, I'm sure it will be very interesting and useful webinar for us today. And this is our agenda for today. So this webinar will run for about 2.5 hours. Firstly, we will have opening speech from the Dean of Faculty of Agricultural Technology, Professor Imam Santoso, and then we will have photo sessions before we go into the main sessions of this webinar, which will be divided into 2 sessions. So the first sessions will be 2 speakers, and then we will go into the Q&A session, the session 1. And then after that, we will start the session 2 of the speakers. There will be 2 speakers as well. And then followed by the Q&A sessions. And then finally, we will close this webinar at around 2:20 p.m. So I think we will have photo sessions first. Sorry, the opening sessions first. So we can see that Professor Imam Santoso has already here. So please, Professor Imam, for your opening speech. Time is yours. Thank you.
Thank you, Mr. Rizky. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon or good evening for Mr. Rizky. The Honorable Professor Dr. Muhammad Nizam Abdul Rahman from University Technical Malaysia, Melaka. Thank you for your time and join with our webinar. And the Honorable Dr. Hairusi Sakirin bin Hashim from International Islamic University, Malaysia. Thank you for your time and opportunity for sharing knowledge and experience with us. And thank you and the Honorable Mr. Arif Hidayat from our faculty, but now he is conducting a postgraduate program, postdoctoral program in Australia. And then the Honorable Mr. Christian Dwi Kusuma from PT Mayora. Thank you for your time. On behalf of our Faculty of Agricultural Technology, University Brawijaya, it is my great honor to welcome you to the Faculty of Agricultural Technology webinar series. This webinar is part of many agenda for celebrating 24th anniversary of Faculty of Agricultural Technology, Universitas Brawijaya 2022. First of all, let us be grateful to Allah Subhanahu wa Ta'ala who has given us health and the opportunity to be able to attend and participate in this webinar. Truly, this is an excellent gift that Allah bestow on us. Then I would like to say thank to some speaker in this webinar, Professor Nizam, Dr. Hairusi, Dr. Arif Hidayat, and Mr. Christian Dwi Kusuma, and all of participants who already attend and support the successful of this webinar. We think that this webinar is very essential as a part of our effort to support our main program, especially FTP UB, to become as one of the center of excellence in agricultural engineering, food technology, biotechnology, agroindustrial engineering, and environmental engineering. This topic today is very interesting. It is related with how to understand and how to develop or implement the innovation-based development and engineering system in agroindustry. As we know that Industrial Revolution 4.0 or smart manufacturing, smart factory is that related with how to utilize internet-connected machinery to monitor the processing, especially in our case in agroindustry. So, computing power, connectivity, artificial intelligence, big data, sensor, and others related with smart factory is very interesting for discussion. This webinar, especially international webinar today, is one of our efforts to collaborate with many parties today with University Technical Malaysia, Malacca, and International Islamic University, Malaysia. Now, in our faculty, various local and international collaboration have been made, several of which have been followed with joint programs such as education and training, research, community services, and joint publication. Several activities have also been initiated with industry or private agencies, leading to collaborative research and application of several product prototype, machine development, or even industrial prototypes. In that context, I believe that collaboration with partners, especially outside and overseas parties, play an essential role in advancing FTP-UB and UB as a whole. I hope you have a productive webinar today, learning a lot of today's experts, and I am looking forward in the future action and other activities, especially initiated and generated from these events. Again, thank you for the speaker. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Imam Santoso, for the opening speech. Indeed, hopefully we will have a very useful and interesting webinar today. Thank you, Prof. Imam, once again. And the next one, we will have photo sessions. So before this webinar starts, we'll take a photo of us. For these photo sessions, I will leave these sessions to committee, to technical committee, please. Is it ready yet, committee, for the photo session?
Yes,
Gentlemen.
Thank you. Maybe for all the participants can turn on the camera if you would like for these photo sessions, but if not, it's fine. Thank you. Is it done yet, or not yet?
Not yet, Pak Kiki.
Okay.
Wait a minute, still on slide 1. Please hold your smile.
Okay, thank you.
Okay, done.
Is it done? All right, thank you very much, committee. So we've had our photo session, so please bear with me a little bit. Right, so now we will start our main session of the webinar. So as I've said before that there will be 2 sessions. So this first one, there will be 2 speakers. So on the first one, we will have Dr. Arif Hidayat. He is an assistant professor. Dr. Arif Hidayat is an assistant professor in Department of Agro-Industrial Technology, Universitas Brawijaya, and he has a PhD from Monash University, Australia, and his expertise and experiences are in around location-based services, including query processing, data indexing in spatial databases. Dr. Arif also the originator of the reverse approximate nearest neighbor query, and he already has several publications in reputable international journals. For today's talk in this webinar, Dr. Arif Hidayat will present an interesting topic once of location-based services in agro-industry. So Dr. Arif Hidayat, you will have around 20-25 minutes for your sessions. So please, the time is yours. Thank you very much.
All right. Thank you, Mr. Moderator. Let me share my screen. All right. Good afternoon, everyone. Thank you for the opportunity that is given to us to share my experience on this area. Today, I will present some basics on location-based services and how it can be implemented in agro-industry. First of all, I will start with what is location-based services. Basically, this is services that are customized based on the geographical location of the user. And some example of this could be drivers navigating with, for example, Google Map. They are alerted with nearby McD restaurant for some promotion, for example, free coffee, or users who check in within her social media platform. They got alerted with nearby popular restaurants among her social network. So these are some example of how location-based services used in marketing. And this is normally the architecture that is used to provide location-based services. We have users that are using their mobile device, and their device are equipped with GPS locator, which is more and more affordable these days. And then these devices communicating with the server via internet. Within this server, we need a sort of spatial database and query processing such that we can store all spatial objects and we can retrieve those information efficiently. And this is actually where our work focus on. So we work on this area, spatial database and query processing. So what is spatial database? Basically, this is just a normal database, except that it focuses on spatial objects. How we store spatial objects, how we index those objects, such that we can retrieve the information efficiently. Yeah. And those spatial objects include points, lines, and polygon. For example, if you use Google Map to show all fuel station close to Universitas Brawijaya, then you will see some information retrieved and presented to you by Google. Basically, behind that query, there is underlying database with with algorithm to quickly answer the query from the user. In this case, you issue, for example, nearest neighbor with text fuel station, and then it will retrieve all those fuel station close to Universitas Brawijaya. There are many spatial queries that have been introduced out there. from the basic one, which include what is the area of A, what is the distance between point A and point B, or whether point A is contained within object B, or proximity-based query, which includes range query, nearest neighbor query, reverse K nearest neighbor query, and so on. This is an example of range query. So given this query point Q, we want to show all users within, for example, 5 kilometers from this query point. In this case, as a human, we can quickly see that there are 3 users that are located inside this radius. And these are our contribution in this area. And today I will specifically talk about our first work, which is called reverse approximate nearest neighbor query. Before we go to this query, so we introduce a new query called reverse approximate nearest neighbor query, which is a complement for the for the popular query called reverse K nearest neighbor. So we have to, I will cover reverse K nearest neighbor query before we go to the newly introduced query. So reverse K nearest neighbor query, or we can call it RKNN query, I think the familiar one for you is what is called as nearest neighbor query. Basically, you want to find the object that is closest to the query point. So if you are in Universitas Brawijaya, for example, or if you are using Gojek, and you make an order there, and the map application will show you the nearby drivers. So basically, that is an example of nearest neighbor query. The next query, which is related to our newly introduced query, is called RKNN query or RNN query. And this query basically try to find all objects which consider the query point as its nearest neighbor. This will be very useful for marketing purposes. For example, if I am, for example, a manager of a restaurant, I want to know which users who consider my restaurant as one of their closest facility. That way, I can, if I have a sort of deal, I can advertise this deal to the potential users. So let me give you an example of our KNN query using this data set here. Let's say we have user 1 to user 4, and we have 3 McDonald's restaurant here. 2 nearest neighbor of Q will be U3 and U2. So these are the 2 nearest neighbor, or the 2 nearest customer, or the 2 nearest user of this McDonald's restaurant. However, U3 and U2 are not the reverse 2 nearest neighbor of Q. Reverse 2 nearest neighbor of Q is U4 because U4 consider Q as one of its 2 nearest restaurant. I know it's a bit complicated in the beginning, but here I tried as hard as I can to make it simple. So U3 and U2 are not R2 and N of Q because U3 and U2 consider F1 and F2 as their two closest restaurants. So in this case, Q will not consider U3 and U2 as their potential customers. Instead, U4 is their potential customer. So that is the basic of RKNN query. Now we will continue with the limitation of RKNN query, which then will be addressed by RANN query. So let's have a look on this example here. In R2NN query, we say that user 2 is influenced by F1 and F2 because F1 and F2 are its two closest restaurants. So if F1 and F2 has F1 and F2 have a sort of deal, they will advertise this deal to U2 because U2 is their potential customer. However, a user that is willing to travel, for example, 30 kilometers to reach its closest restaurant, we argue that this user will not mind to travel slightly further. Okay, so in this case, let's have a look on McDonald's restaurant, which is called F3. If F3 is to R2NN query, U2 will not be considered as its potential customer. While in fact, U2 is actually its potential customer. Why? Because U2 that is willing to travel 30 kilometers to reach one will not mind to travel 1 kilometer further to reach F3. Or let's take an example. If you know Malang, if you know Wakir, I live in Wakir. The closest McDonald's restaurant from my hometown is, let's say, McDonald's restaurant in MOK. So if I have traveled, for example, 15 kilometers to McDonald's restaurant in MOK, then I will not mind to travel slightly further, for example, to Sarina to find my next closest McDonald's restaurant. So this is the limitation of RKNN query that we try to address here. Because if we use RKNN query, then U2 will not be considered as potential customer of F3, which is actually inaccurate. So here we introduce a new query called RANN, where given a set of users and a set of facilities, so we call the spatial object that provides service as facility, and the spatial object that use the service, we call it user. So given a set of users U, a set of facilities F, a query facility Q, and a value of X greater than 1, RANN query returns every user for which this requirement is met, where NN this U denotes the distance between U and its nearest facility. I know this may sound not very interesting for you, but let's try to follow this. Okay, and the challenge here, if we want to solve the RANN query problem, is yeah, let me give you a basic example of a spatial query. Let's get back to this range query. We have a query point Q, and we have a set of users from U1 to U10. We want to find all users within 5 kilometers from Q, for example. As I mentioned before, as a human, we can quickly see that U6 and U10 are the query answers. However, yeah, unfortunately, computer only sees number. So this is what computer sees, just the number. And even worse, in the machine level, it is just zeros and ones. So with these all numbers, how we can ask the computer to quickly, to efficiently find these 2 points, the points that are located within this radius from the query point. So that is the basic challenge for all spatial query. So we use what is called as R3, spatial indexing. So with R3, all spatial objects are placed within a virtual rectangle. So if we have point A, B, C, D, we will have rectangle R3 to cover A and B, and then another rectangle R4 to cover C and D, and both R3 and R4 then covered by bigger rectangle called R1. And similarly for this rectangle here. Now with this index, if we want to know which point that is located within radius R from the query point Q, we don't need to check each point one by one. If we do not design a sort of algorithm and indexing for all spatial objects, then the computer have to scan all points and check whether this point is located inside this circle or not. And scanning all points, which is called as naive approach or brute force approach, is prohibitively expensive because if we talk about the complexity of that algorithm will be ON, where N is the total number of points in the data set. You can imagine there are million or trillion points stored in the Google Map. If you issue a query, for example, show me the nearest McDonald's restaurant, if Google Map has to scan all McDonald's restaurant within the world, then your query will be returned maybe in 2 or 3 hours or even 1 day. So there has to be a sort of spatial indexing and algorithm to make the search to be efficient. And R3 is one of that special indexing. So for example, with R3 like this, if I want to find all points within this circle, I will first open the root of this R3. The root basically a rectangle that contains the whole data set. And then this root node, because this is a tree, and tree normally has root, it has child node as well. So once we open the whole the whole R3, it will see these two rectangles, R2 and R1. And then the algorithm will check if R1 overlap this circle, we will open it. And then we will put all the children of R1, which is R3 and R4, into a data structure called heap or priority queue, which is sorted according to minimum distance to queue. And we continue that process, and we stop once we find a rectangle that does not overlap this circle. So this way, the computer just need to open and check few points. It doesn't need to scan the whole points within the data set. So for example, if the minimum distance between this query point to rectangle 7, for example, is greater than this, the radius of this circle, then R7 will not be open. And since all entries are stored in a priority queue, once we see an entry that is not open, then the search terminates. So that is the basic of the data indexing, which allow efficient search algorithm. Right. So another challenge with our ANN query is that it cannot use the existing popular pruning. So pruning basically when we are given a query, when the computer is given a query, it will first compute the area on which users inside this area cannot be the query result, and this area will be pruned from the from the search space, and that is called pruning. And if, for example, if we work with nearest neighbor query or reverse nearest neighbor query, given this query point, let's say this is a McDonald's restaurant, this is another McDonald's restaurant, and we draw a perpendicular bisector between A and Q, so we can guarantee that all users inside this half space will not consider Q as its closest restaurant. Similarly, all users within this half space will not consider Q as its closest restaurant. So this is what is called as half space pruning. With half space pruning, we can quickly prune much search space so that we can work only with this small search space, which significantly reduce the searching time. But the problem with our ANN query is that we, for example, here, we have this query point here, and we have, let's say, A, B, C, D, E, F, McDonald's restaurants. We cannot quickly say that U2, because it is far from Q, it will not be the query result. Because U2, which is far from Q, may consider Q as closer than X times its closest restaurant. So this is another challenge of RANN query. So to address those challenges, we introduce what is called as point-based pruning. So we prove that given a query point Q, let's say given a McDonald's restaurant Q, another McDonald's restaurant P, then we can guarantee that all users within this circle will not consider Q as its closest facility. So all users within this circle will not be the query answer of Q. Yeah. So this is point-based pruning. And also we have another pruning called MPR-based pruning, which is slightly more complex than point-based pruning. I will just skip this. And those pruning are then implemented in our algorithm. So this is how our algorithm works. Given a facility R3 and a query point Q, we want to find the query answers of Q from the dataset. So the first step will be inserting the root of facility R3 in a priority queue or a heap. And then while heap is not empty, we will keep opening the heap and and so on and so forth. Yeah, you can follow this yourself and then clarify it with me if it is not clear. And with this pruning algorithm, we may still end up with too many circles. So still we have to do a sort of improvement here, because in the worst case, we may have the number of circle equal to the same number of facilities in the worst case. So to address that problem, we use another data structure called interval tree. So for each circle, we will put that in the interval tree such that the filtering process can be done efficiently. And we tested our algorithm against the real world data. We use the map from North America, Los Angeles, and California. And we compare the performance of our algorithm against basic range query and improve range query. Since this is new query, so there was no existing work on this query, so we devised another algorithm which become the competitor of our algorithm. And from the experiment, we can show that our algorithm is several order of magnitude better than the improved algorithm. You can see from the CPU cost here. CPU cost means the time that is needed to answer the query. Our query needs only 2.95 milliseconds, whereas the improved range query and the basic range query needs a lot more than that. Yeah, and we we test our algorithm on different parameters like the value of X, the different data set, and also in the different number of facility and users. And in all those experiments, we find that our algorithm is significantly better than the competitor. So that is an example of our work in spatial database and query processing, and how it can be implemented in agro-industry. So basically, all algorithm, all queries that have been introduced can be implemented in industry, not necessarily agro-industry, because it has nothing to do with the characteristic of the product. It just search from the huge data set what is the query answer. But let me highlight some of them that may be relevant to agro-industry. If, for example, we want to build a treatment site or waste landfill site, because this is the waste treatment site, then we want it to be as far as possible from the settlement, from the community. So we can use what is called a reverse K farthest neighbor query to to decide the best location for this landfill or treatment site. Or similarly, if we want to, let's say we want to we want to have another branch of our restaurant, for example, and we want to build this branch in a location such that it will minimize the competition between between the branches. So again, for this purpose, we can use a reverse K farthest neighbor query. Or another example, if we, for example, if we have Bulog. Yeah, Bulog has many warehouses. We can split the area using Voronoi or network Voronoi diagram to to determine the coverage area of each warehouse. Or similarly, if you still remember a few years ago in Indonesia, we have a new admission system for primary and secondary school, which using zonasi. So we can use this as well to quickly determine the correct school for each student, like which one is the closest school for all users. And also for target marketing, let's say you are using social network, Facebook, for example, and in Facebook you have many friends, and we can quickly find from your check-in and from your network check-in, from your friends check-in, we can find the most popular restaurant among your group. So let's say if one of your friends check in within a city, you can quickly recommend to her what is the most popular restaurant here, which is which is popular among your friends, and we can recommend you such information using geosocial group query. All right, so I think that's all for my presentation. Pass back to you, Mr. Moderator.
Right, so thank you very much, Dr. Arif, for the very interesting topics, and you can give a virtual applause if you want from the participants. Thank you very much again, Dr. Arif. And for the next speaker, please bear with me for a moment. Right, so for the next speaker 2, we will have Professor Nizam from Malaysia. Professor Nizam is a professor at Faculty of Manufacturing Engineering, UTM, and he has PhD from Coventry University in the United Kingdom. And Professor Nizam has research areas of thin film coating, machining, cloud manufacturing, and engineering management. So, and also Professor Nizam has a very vast professional experiences, including working in Intel Malaysia as engineering manager and materials warehouse manager, and also Blue Ridge Pressure Casting Incorporation, United States of America, as process engineer. And also Professor Nizam has vast administrative experiences as a director of International Relations Office and as Deputy Dean and also head of department. So Professor Nizam will be giving an interesting topic of talk of cloud manufacturing today. And so just before we start Professor Nizam's talk, just to remind the participants that if you have any questions, you can type in the chat box, or alternatively, you can speak to your microphone during the Q&A sessions. Right, so Professor Nizam, when you're ready, so please, time is yours. Thank you very much, Professor Nizam.
Thank you. Let me share my presentation first.
Yep.
All right. So let's see. So Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to all. So first and foremost, I would like to thank the organizing committee, especially Dr. Sri Suhartini, and also the Dean of Faculty of Agriculture Technology, Professor Iman Santoso, for inviting me to this particular session. So thanks a lot. Before I proceed, I would like to also congratulate the rest of the faculty members for their 24th anniversary. Right? The topic that I'm going to cover today is cloud manufacturing. Before I go any further, I would like to answer two questions that I usually get whenever I share this information. So the first question that usually asked upon me when I presenting these particular materials is this similar to cloud computing? So the answer is no, it's not. It's different. It's not similar. There is some connections with the cloud computing, but it's not the same thing. And the second question that I usually get is, why do you want to manufacture cloud? So the answer to that is basically this presentation is nothing to do with the cloud, on the sky. So it's something different. I'm going to elaborate a bit more on it after this. Quickly on my outlines of my presentations. Quickly, I'm going to look go through the manufacturing paradigms and comparing cloud manufacturing and industry 4.0. And then I'm going to zoom down on cloud manufacturing itself, talking about the structure, ideal characteristics, gaps, and conclusions. Okay. So questions. So if I ask these questions, have you heard about Industry 4.0? I'm quite sure that most of you know what's Industry 4.0. Sometimes it's called IR 4.0. Sometimes we call it CPS, cyber physical systems, so on and so forth. So most often than not, people knows about what is Industry 4.0. But when mentioned cloud manufacturing, most often than not, some of you knows about cloud manufacturing, but most often than not, a lot of people don't really know what cloud manufacturing is all about. And when I'm not familiar with the enduring system research in the agriculture sector, but I did browse through a white paper written by the World Bank on the digitizations of the agro industry. When I look at that particular plan, it's actually following Industry 4.0 footprint. And so the main purpose of me sharing a cloud manufacturing in here is maybe to entice and also to maybe hopefully by knowing cloud manufacturing a bit, then the researcher in the digitization of digitizations of the agro industry will take some key point from cloud manufacturing when you implement automation or digitizations of agriculture industry. So that's basically the main purpose of it. So I'm going to do the comparison. So I'm going to make a comparison, a quick comparison between Industry 4.0 and cloud manufacturing. So basically, Industry 4.0 or cloud manufacturing is manufacturing a paradigm. And there are two schools of thoughts with regards to the evolutions of the manufacturing paradigms. So there are two mazhab if we do a comparison in religion. There are two mazhab, two schools of thought. So one school of thought is basically saying that the evolutions of manufacturing paradigm is from Industrial Revolution 1, the first Industrial Revolution, where you first to use a steam engine, and then come to second Industrial Revolutions, where you have a production line, and automations come in third Industrial Revolution, and currently we are in the fourth Industrial Revolutions, talking about cyber physical system. So that's one school of thought. So the alternative to that, a group of scholars actually proposed that the manufacturing paradigm evolution start from the assembly line, Toyota production system, and then flexible manufacturing system, and RSM with configurable manufacturing system, and now is cloud manufacturing. So there are two school of thoughts in defining what is the latest and greatest manufacturing paradigms. So one group say that is Industry 4.0, and the other group say that is cloud manufacturing. But most of the attention of the researchers and practitioners in the world currently is focusing on Industry 4.0. So I just want to chip in some information about cloud manufacturing that might interest you when you embark on the research on digitizations of agro industry in the future. So let's look at the research work done in both areas. So one of the way to do it is basically look at the publication for those two areas. So what I share here is basically Scopus publication statistics using two keywords. One is cloud manufacturing, the other one is Industry 4.0. And I'm looking at a number of publication, country of origin, and funding providers. So if you look at the number of publications for cloud manufacturing, it's in the range of about 160 per year for the past 2 years, right? Compared to Industry 4.0, which is around 3,000 plus, 3,200 for the past 2 years. So a lot of concentrations, a lot of efforts has been put, and a lot of focus being put at the Industry 4.0 activities. And when we look at the country of origin of the research, so most of the research on cloud manufacturing is coming from China. So you can see a huge gap between the publication coming from China and the rest of the world, right? And if you look at the publication on Industry 4.0, then majority of it is coming from Europe, India, United States, UK, so on and so forth. China is there, but somewhere on the 5th place. But you can see on the cloud manufacturing, China really put some emphasis on it. Right? Similar to the funding provider, people put money on the research that would interest them in long run, and basically China put quite a bit of money, substantial amount of money, in research on cloud manufacturing. And whilst European organizations put money on Industry 4.0. So you can see in terms of publication statistic, it shows who's doing what research, and I'm going to try to answer why later on in my presentation. So let's look at the Industry 4.0 versus cloud manufacturing, the differences and the emphasis. So when we talk about Industry 4.0, the scope is basically vertical and horizontal integrations of manufacturing activities. And the emphasis is basically so that you can make the manufacturing activities faster, more efficient, and more customer-centric. And bottom line, in Industry 4.0, what we're trying to achieve at the end is basically mass customization. Right? So I'm not sure whether you are familiar with the mass customization concept or not, but I'm going to share with a very simple example. Let's say, for example, if you manufacture a shirt, right? So if I'm in the, so I want to differentiate between mass production and mass customization. So if I'm in the business of manufacturing a shirt, so in the mass production mode, then I'm going to manufacture maybe 10,000 shirts for every single size there is, maybe a size 14, 10,000, 15, 10,000, so on and so forth. And then I'm going to put those shirts in the store. So when the customer wants to purchase a shirt, they just go to the store and find the closest fitting shirt for them. If their size, let's say, for example, the exact size is 15.25, then maybe they will just choose the shirt size 15. Okay? So they can immediately purchase and wear the shirt. Right? So the alternative to that is basically, if you want to get more comfortable shirt, then you can go to the tailor, right? So you go to the tailor measure your measurements. So exact measurement. So maybe the neck size is 15.25. And then the tailor will cut the fabric and then sew them. And then maybe 2-3 weeks, 2-3 days after that, you can come into the tailor and then pick up your shirts, custom made shirts. So basically, the mass customization is the combinations of the two. The idea is how to customize a product to your customer requirement at the efficiency of mass production. So that's basically the bottom line of Industry 4.0. That's what it's trying to achieve. So in that particular situation, if you achieve mass customization, then basically, if you want to buy a shirt, you go to the store where there is maybe there is an auto system that take your measurement within 5 seconds, and that information is passed to the CNC cutter, which cut the fabric within let's say 2-3 within another 10 seconds, right? And then there's automated system that sew all the fabrics together become shirts, and you can get your shirts within, let's say, for example, 5 minutes, right? So if you achieve that, then basically, if you achieve that at the efficiency of mass production, meaning that your cost will be down, and the customer can get the product that they want, exactly what they want, cater to them, tailor to them, within a short period of time. So Industry 4.0 activities actually trying to enable that to happen. Whereas in cloud manufacturing, the focus is totally different. The basic fundamentals for cloud manufacturing to happen is similar to Industry 4.0, meaning that you need to have automations, both on physical system and also data automations. You need to have digitization, so on and so forth. But the focus and objective are different. So cloud manufacturing focuses on the integrations of various components. Usually it's horizontally. I'm going to explain to you what it meant. To enable manufacturing as a service. So the focus of cloud manufacturing activity, platform research, so on and so forth, is to enable manufacturing as a service. What it means that offering of on-demand manufacturing services for the whole life cycle of manufacturing, from design up to test, maintenance, and even recycling. So the focus is totally different compared to two. One is to achieve mass customization. The other one is to enable manufacturing as a service. And I'm going to expound on this topic, what it meant by manufacturing as a service in next slide. Right. So this is a comparison, a quick comparison between the system, Industry 4.0 system on the left-hand side, and on the right-hand side is cloud manufacturing. So if you look at the Industry 4.0, I'm not going to explain in detail on this because most of you knows what it's all about. So you're talking about vertical integrations, means that you need to have automations and digitizations within a factory. And then you need to have also automation and digitizations of those entities within the network. So this is horizontal integrations, and this is the vertical integration, right? So if you do this integration, then basically you're going to be able to optimize the process, reduce the lead time due to online communications, almost real-time communications and data sharing. So Industry 4.0 is set up as such. For the I'm not sure how to take this thing up. So for the cloud manufacturing, basically it consists of 3 domains. One is the consumer domains. Second one is the platform domains, and usually we call this a cloud platform. And the third one is a physical resource provider domain. We call it PRP. So customer is a customer, the end user customer. Usually this is somebody who has idea and who has a design of a product. So let's say, for example, I have idea to make a product, right? And I have a design in terms of drawing, specifications, so on and so forth. But I don't have factory, right? So my option is basically I can source for outsourcing, or I can build my own factory, right? That's the current option that I have. So the physical resource provider is basically, these are numbers of companies around the world which has a certain capability and certain capacity. For example, supplier one might be in the welding process. Supplier two may be on the CNC machining process, so on and so forth. Right? So what happened? I'm just going to explain how the interaction between these three domains. So when a customer has a product design, and he doesn't have capital to actually build a factory, and he wants to do it fast. So if there's this cloud manufacturing platform, then he can actually submit his design and specification to this cloud platform. At the same time, all these various companies around the world can register and submit their data as a database in the cloud manufacturing platform in terms of their capability and their capacity. And this is talking about instance data, meaning in situ data, means that it's real-time data. That's the ideal case. Meaning that at that particular moment, the cloud manufacturing platform would have informations of all these suppliers' informations with regards to their capability and capacity. Right? So once the information from the customer log into the database, and the cloud platform has already a database on the supplier, PRP supplier, right? So the next step is basically the intelligence and assessment and optimizations module will take over. Basically, this module will do a compatibility assessment and optimizations engine in matching the customer and the potential supplier, potential PRP. Right? And it takes into account the energy requirement, the distance requirement of shipments, so on and so forth, and user ratings, so on and so forth. So once that matching is happening, then decision-making module will actually come up with a production strategy and manufacturing solutions and give that information back to the customer. So maybe the system say that, okay, if you want to make these particular parts, then it will cost you 10,000 ringgit per parts. Basically the shipment, the lead time will be maybe 1 week. So those are kind of information that's given back to the customer. And if the customer say okay, then basically that information will be routed to the suppliers, to the identified PRP for the parts to be fabricated or manufactured. So these are so if you are a supplier, meaning that if you have a small company somewhere, let's say for example in Malaysia, and I want to have my company capability and capacity visible at the global state, then basically if there's such a platform, cloud manufacturing platform, then I can engage into that platform and I can compete at the global level, right? Even though I'm a small company, right? I think that's maybe one of the reasons, I don't have hard concrete data, that China is actually pushing this particular concept. Because in China, there are many companies, very small companies and medium companies that have capability and capacity for various manufacturing activities. So in order to help this company to compete at the global level, then if there's a cloud manufacturing platform exists, right, then it can help that company to compete at global level. And for the industry 4.0, in my opinion, the main beneficiary of that particular system is a big company, big organization that has a first tier, second tier, fourth tier supplier. Where if all these suppliers abate to the industry 4.0 initiatives, then basically you can cut a lead time, and the owner of the product, usually it's a big organizations, can actually cut their costs down quite a bit with regards to inventory, reject rate, obsolescence rate, so on and so forth. Right. So some of the main benefits of cloud manufacturing, basically the matching between the user's demand and the production system owned by the PRP. So again, PRP is the physical resource provider. The first one is allow manufacturing companies around the world to be visible and compete in the global platform. So that's the first thing. So so even if you're a small company somewhere in Indonesia or in Malaysia, right? So if you participate in this particular platform, then basically we are on the map, in the global map, and other companies can find us. That's one. The second is shorten time to market of a new product. So if you have a new product and you want to actually build your own factory to manufacture that particular product, it takes time. But if you use the cloud manufacturing platform, then basically the capacity is there already. The expertise is there. You just use it. Just pay for the service of manufacturing it. The third and the fourth benefits are quite related. One is minimizes capital investment. The other one is optimizes the utilizations of the PRP resources worldwide. So example of this, I'm just take a snapshot, but this is all data, is snapshot of the capacity utilizations around the world. And this is coming from Trending Economics. So it indicates the manufacturing capacity utilizations in 2017-2018 for various countries around the world. So if you look at it, there are some country has a very high utilization rate, but there are some countries with a low utilization rate. So if you have this cloud manufacturing platform that has visibility in terms of where the excess capacity of certain manufacturing activity is, then basically you can optimize the utilizations of the PRP resources around the world. So if you can do that, then basically you can minimize the capital investment, and as a whole, I think you can lower the carbon footprint, so on and so forth, and it's better for the world. And if you do that, then basically the cost benefits we can pass it to the end user of the product. So these are some of the benefits of cloud manufacturing. So so I'm going to share quickly the 8 requirements. I hope I still have some time. Okay, I'm going to share quickly on the 8 requirements of ideal cloud manufacturing environment. This is for manufacturing. Oh, by the way, interesting enough, if you think about it, right? So if you implement this for the agro industry, so maybe there's a requirement for tapioca somewhere from Europe, right? And they want to source a supplier. So if the supplier, if there's such a platform, and there's a supplier, a small supplier from Indonesia or from Malaysia, log into the system, right? Then basically that small farmers somewhere in Malaysia or in Indonesia can actually compete to get that order from Europe, right? So there's examples of applications of this particular paradigm, manufacturing paradigm in agro industry. So just sharing the 8 requirements for the ideal cloud manufacturing environments. The current practice is not ideal yet. So, so the researchers and practitioners in this field is marching towards this ideal situation. The first one is, it's being hidden here. The first one is the 3 layers should be connected through social media-based services to facilitate communications and data knowledge sharing. So the platform, cloud manufacturing platform, should be on the social media-based services in the internet, so that everybody can communicate and can participate. There should be the second requirement is there should be a cloud-based data sharing capability for the cloud manufacturing player to access and share manufacturing related data. So the developer of the cloud manufacturing platform must actually provide the cloud-based data sharing capability so that the user can upload their requirement, and the PRP can also upload their capacity and capability in the system for the matching to be done. The third requirement is open source programming framework should be developed to process, manage, analyze data stored in the cloud. So this is to ensure decentralizations of this particular platform. So you want to make sure that the algorithm that you use can be checked upon to be fair by whoever want to participate in that particular platform. So because of that, then open source programming framework is very important to ensure decentralizations of data and decision-making activity is transparent. The fourth one is CM should provide a multi-tenancy environment where single software can serve CM players. So these examples of this is some of the activity during the product life cycle is maybe there's a requirement for example, computer-aided engineering analysis using certain software that, for example, using SolidWorks, right? So CM, a cloud manufacturing platform, should provide a software which is SolidWorks for that particular example, and the user can use that particular software by paying fractions of the amount if he or she has to purchase that particular software themselves. So they just pay for the time that they use that particular software. So that actually will optimize will make the whole process is much more efficient. The fifth one, basically the cloud manufacturing platform should be able to collect, store, and monitor real-time PRP's manufacturing data. Not only that, also remotely control the manufacturing resources. So once the ideal case is once the physical resource provider define their capability and capacity in the cloud manufacturing system and share the real-time data of their activity, right? So the cloud manufacturing platform organizer should be able to load them as the requirement coming in from the end user. Right? The sixth one, CM should be implement service-oriented model, putting user needs and goals as the center of the operation, not the platform, but the user needs as the center of the as a goal of the platforms. CM should assist user in finding suitable manufacturing resources in the cloud. So this is the matching exercise that I defined just now. And the last requirement is basically CM should provide instant quotations online upon user specification. So the ideal case, basically once you download your requirement, your drawing, so on and so forth to the platform, cloud manufacturing platform, immediately you get a response in terms of quotations, you know. So for so much, for let's say 1,000 units, then the cost is $10 per unit and will be delivered to you within 10 weeks. So in instantaneous quotations is the ideal case for cloud manufacturing platform. So, but currently it's not there yet. Currently it's not there yet. So some gaps ideal versus the current industry adoptions of cloud manufacturing. So the first issue that's faced by the current cloud manufacturing system is interfactory integration within the CM. So this is examples of this. If a customer come up with a product and that particular product requires, let's say, 5 manufacturing steps: welding, machining, milling, and also, let's say, coating. And all this capability resides in different company within that particular PRP's pool. So the integration between the companies within that particular pool is still lacking. Reason, for example, the main reason being, if there's a quality issue, then how do you identify which particular factory actually responsible for that, so on and so forth. The second gap is instantaneous quotations of the requested service, still not there yet. So you still have to wait a day or two for the quotation for you to get a quotation of your submission of proposal. And there is a lack of real-time monitoring control, real-time data, PRP resource performance and capacity. So this is very much related to Industry 4.0 activities. So if you can implement CPS, cyber physical system, for all the PRPs, then basically this is no issue. So in certain level, there are some relationship between IR 4.0 and cloud manufacturing, but the concept and also the objective are totally different. Potential research area in cloud manufacturing, standardizations of the PRPs and user input variables to develop universal manufacturing cost modeling for various manufacturing process. So if you can do this, this will assist in terms of instantaneous quotations once you submit your design to the cloud manufacturing platform. The second one is integration of real-time monitoring, control data, resources, allocation algorithm, and sharing strategies. So this is this is very much related to IR 4.0 subject actually. And the other area of research that can be done in this particular platform is integration of all supply chain components in the CM. So you're talking about how do you integrate a raw material supplier, a logistic provider, so on and so forth, into this system. So that's another thing that can be researched on. And the last one is information security concern, and this is actually a big concern among the players in the CM. So in conclusion, CM has been recognized as emerging manufacturing paradigm that can provide cost and flexible advantages. But there still gaps exist between the ideal CM model and current state of the CM implementations and research. I think personally think that CM would greatly benefit small and medium industry to compete globally. So this is something that's important for Malaysia, especially. So in Malaysia, 95% of the companies, manufacturing companies, is small and medium industry. And a CM concept can be adopted and adapted to the digitizations of the agro industry initiatives. So these are basically some of the some of the CM platforms available out there. If you want to browse through, Fast Radius, manufacturing.com, and Factory. So basically that's the end of my presentations. I hope that some key points that I shared with regards to cloud manufacturing can be benefited and also entice and trigger some interest among the researchers in the digitizations of the agro industry, to take some input and some good strategy of the cloud manufacturing during implementations of these digitizations of agro technology. So with that, thank you very much, and Assalamualaikum.
Waalaikumsalam. Thank you very much, Professor Nizam, for the very interesting topics of talk. So we will now going into the first questions sessions. There will be 15 minutes for these question sessions. So please, once again, if you have any questions, you can put the questions in the chat box, or you can speak through your microphone. So for these sessions, the questions should be addressed to Dr. Arif or Professor Nizam. So far, I have seen only one question. This one is for Dr. Arif. The question is from Mr. Aunur. So the question is, most of the examples you presented are about querying spatial data in the form of points. But in many agro-industrial applications, what we need are spatial data in the form of lines or polygons. Could you please explain how the algorithm you presented can be used to query lines or polygons, geometric shapes? Dr. Arif, thank you.
Thank you for the question. It's a good question, actually. I can say that our algorithm can directly be implemented on polygons or other geometric shapes, because yeah, actually when we implement the point, when we write a code to represent point, we actually treat this as a rectangle. So when we present rectangle in a computer, we use bottom left corner and top right corner. So we use these 2 points. So a point basically is a rectangle that has the same bottom left and top right. So that's how we implement point in our code. And yeah, basically, if it is a rectangle or other regular polygon, yeah, provided that is not irregular shape, then it is actually easier, because then we don't need to to handle more object. For example, if you remember range query that uses R3, we put all points, let's say we have 100 points, we encapsulate them into a rectangle. So we check if the minimum distance to this rectangle is greater than the radius, then this all 100 points can be ignored, can be eliminated. So if we use polygons, then I believe it will be even faster in terms of computation. If previously we compare a distance between 2 points, we can use a minimum distance between, for example, 2 rectangles. Yeah, I think that is my answer.
Thank you, Dr. Arif. Is that fine, Mr. Aunur, or you have any response to Dr. Arif's answer? Right, so it's fine. Thank you very much, Dr. Arif and Mr. Aunur. Any other questions from the participants, please? If you have any questions, you can type it in the chat or speak through your microphone. Okay. Okay, so if I may ask you some questions, Dr. Arif, actually I have so many questions because your topics is very new to me. But if I can ask just a simple questions, what is the input of data required for the analysis that you explain? I mean, is it locations, distance, or various variety of data? And what are the tools required to for the data collection? I mean, is it questionnaires or observations. Maybe you can explain that a little bit, Doctor. Thank you.
Thank you. Thank you, Pak Rizky. So basically, we use the real world data. So we collect the data from OpenStreetMap. As I mentioned before, in our experiment, we use North America map, for example. So we extract all point of interest from the map, and then we run our algorithm against that data. So the data is basically already collected by OpenStreetMap, and it is we can just use that in our algorithm. So the data in the form of longitude and latitude. So every point is represented as longitude and latitude, and yeah, and then we query from those huge data, and we see that our algorithm can perform good in that real world data.
All right, thank you very much, Dr. Arif. Any other questions from the participants? No. So if I may ask a questions for Prof. Nizam. I don't know about the differences between Indonesia and Malaysia in terms of the small or micro businesses, Professor Nizam. But if you could kindly explain a little bit about what about the applicability of cloud manufacturing for the Indonesian micro or small businesses, Professor Nizam? I mean, you know, the Indonesian micro and small businesses are, so many of them are still in the form of house industry, where I believe that some of them doesn't even familiar to internet, you know. So what do you think about the applicability of cloud manufacturing, Dr. Professor Nizam? Thank you.
Mr. Rizky. So, I think the conditions of small and medium industry in Malaysia and Indonesia maybe not that much difference. Basically, the penetrations of internet or computer-based operating system, so on and so forth, in SME in Malaysia also quite limited. But I mean, we have, in my opinion, the government and also us as researchers and practitioners in this field has a role to play in getting that information out there, making sure that they realize these are the opportunity that you have if you implement certain if you participate in such activity. And at initial stage, current initial stage, I think you don't have to do automations in your production area in order to participate in the cloud manufacturing activity that exists now. What you have to do is you have to make sure that you have good planning system and able to identify your capability for those that kind of data to be uploaded into the cloud manufacturing platform. So it can start from there. So the idea is to ensure that our players can participate at the global market in order for us to become successful in the future. And I think many companies many small and medium companies in China is doing that. And I think they have a very good support from government and agencies in China in doing that. So I think that thing can be implemented at a smaller scale in our countries.
All right, thank you, Professor Nizam. I don't see any other questions, but if I may ask another question, Professor Nizam, you presented an interesting comparison diagram of industry 4.0 and the cloud manufacturing. Yes. So I can see in the industry 4.0, there are pictures of, I presume those are physical factories for productions, and those are not found in the cloud manufacturing diagram. So I just wondering, What about physical factories in the cloud manufacturing, Professor? I mean, does it not needed or any other kind of productions? Sure. Thank you.
Sure. So let me answer that questions using some analogy. So if you so currently with the cloud computing that we have prevalent in our society, right? So I want to, let's say for example, I want to have certain amount of data storage, right? So I can purchase that data storage. Okay. So who sell that data storage? That data storage is sold by somebody in somewhere in internet, right? So does that guys has a physical data storage capacity somewhere? Maybe not. Maybe the physical data storage capacity is somewhere owned by somebody else. Okay. Right. So that guy that you purchased, the company that you purchased that data capacity is maybe is a middleman, it's a platform. So similar to that, then cloud manufacturing platform is a platform. And the purpose of this platform is to match the requirement from the end user who has a design of a product, but doesn't have a factory to make it, and matching that requirement to the various industry around the world that registered in that particular platform. So the cloud manufacturing platform will do the matching exercise between the requirement of the design of the product with the capability and capacity of the physical resource provider. So the owner of the physical machines is actually the PRP, physical resource provider. All right. I hope I explained that.
Yeah, thank you very much, Professor Nizam. Yeah. I can't see any other questions, so that's it for this first question session. Thank you very much, Dr. Arif and Professor Nizam, for the very interesting and useful topics of presentations. And
thank you, Mr. Rizky.
Thank you, Professor Nizam. And before we get into the second session of talks today, I think the committee will present certificates for Dr. Arif and Professor Nizam, I think. And I will handle it to you, committee. Please, thank you. I'm sorry, I was muted. Sorry for that. So this is for Professor Nizam. Thank you very much, Professor, for your contributions and participations as a speaker. And I think the committee will send this certificate by email also to you. Thank you very much, Professor.
Thank you very much.
Thank you. And
thank you, Professor Nizam.
Thank you.
Yes.
Thank you very much.
Representative of our faculty as a dean, I would like to say thank you very much for Dr. Nizam, and we hope that next time we can make other collaboration in research or in the publication or in the other academic activities. Thank you very much.
Thank you for the offer. Vice versa, I think we are also over here quite excited with such a collaborations and opportunity to collaborate as such. So this is to ensure that we are firm in our belief in internationalizations of our education system. So thank you a lot. Thanks a lot.
Yes, yes, thank you.
Thank you, Professor Nizam. Thank you, Professor Imam. Thank you. And this certificate is for Dr. Arif. Also, thank you for your contributions, Dr. Arif, on the very interesting topic. Thank you.
You're welcome, Pak Rizky. Thank you for the opportunity as well.
Yeah, thank you, Dr. Arif. Thank you very much.
Terima kasih, Pak Arif.
Sama-sama, Pak.
Right, so that's the end of our first session of webinar today, and we are now get into the second session of speakers. Please bear with me for a moment. So there will also be two speakers in the second session. With the first one will be Dr. Syakirin. Dr. Syakirin is an assistant professor at International Islamic University Malaysia. He holds a Doctor of Philosophy from University Technology Malaysia. And Dr. Syakirin's research areas are waste management, facilities management, carbon management, and other areas, I think. And Dr. Syakirin has vast various professional consultancy and community-based activities on his experiences. Dr. Syakirin will deliver today's talk in the topic of agriculture and agroindustry 4.0 digitalizations. Just before we get into Dr. Syakirin's talks, just to remind everyone that you can type your questions if you have any in the chat box, or you can speak through your microphone. And also there will be an attendance form during the second question sessions for you to fill out. So, right, Dr. Syakirin, the time is about 20 to 25 minutes. So please, the time is yours. Thank you very much.
Okay, thank you, Mr. Rizky. Can you hear me?
Yes, we can hear you clearly. Thank you.
Thanks. Okay, just allow me to share. Okay, can you see the PowerPoint presentation?
Yeah. Yes. Yes. Thank you.
Okay, thank you. Okay, first thing first, before I start, I would like to thank the organizer, our moderator, and Prof. Imam from the university, from the Briwijaya University, I think. Sorry. I'm sorry because my health is not in a good condition. I have a strong fever since last night. Hopefully, it's not the COVID-19 infection. Hopefully that afterwards I will take another medication in order for me to because right now I'm in my quarantine in my home. So allow me if any sound problem and anything, just ignore it. Okay, and hopefully that I can deliver my speech smoothly, even though perhaps sometimes I have quite batuk, cough. Okay, so the topic that inshallah I will share during this, at least hopefully that within 20 minutes, is on the agriculture and agro-industry 4.0 and the digitalization for this agriculture and agro-industry. Okay, perhaps some of my presentation have been covered by the previous speakers, okay, especially on the industrial 4.0 and also the agriculture 4.0. But by the end of my presentation, I just would like to share some of our projects, research projects, two projects. One is currently we are doing it, okay, the research on the agriculture, digitalization for agriculture, and the second one on the food safety. Okay, inshallah I will share with you by the end of this talk today. So first thing first, I would like to just to give you an overview. What are the issues currently related to our food security, related to ourselves as a human being? Okay, currently we are living with another 7.6 billion people, and the scientists have predicted, but by 2050, we will be living together with another 10 billion people. So we are talking about numbers of population, and therefore, and currently, according to this, only 1.4 billion are working in agriculture. Okay, and this I believe that is not appropriate to what to compare with the numbers of the total numbers of population. Currently is 7 billion and approximately to 10 billion afterwards, but still we have only 1.4 billion people are working in agriculture. So Malaysia is not considered as agriculture countries. Perhaps before 1980s, yes, we are as agriculture countries, but after that, so we are moving towards to the manufacturing countries. So, but currently we are trying to looking back to the agriculture, okay, as being some of issues related to this food security, especially this year in 2022, and also December last year, we have problems with food security in our country. In terms of rising prices, is some of our food. Okay, even though I believe that as a human being, as a layman, I think why is it hard enough for us to just to plant something, because we have soil, we have enough location base, we have spaces, but the problem is perhaps is not in our control, like what happened nowadays is about the climate change. Okay, and if you look at this, what happened if degrees of temperature increase from 1 to 5 maximum degrees. So currently we are at the 1.5 the temperature increase. Okay, but the United Nations tried to stop our progress to increase the from increasing the temperature not over than 2 degrees Celsius. But what happened if we reach to 5 degrees Celsius maximum? Okay, so if you look at these figures or this graph, that it shows that it will be a significant extinction around the globe. Okay, for the ecosystem, and for food also, it will become very complex, localized negative impacts on smallholders, subsistence farmers, and fishers, and so on and so forth. So we are talking about the very negative impact to the whole nation, to the whole population. Okay, so perhaps it has been promised in our Quran that this is the final years of our human civilizations. Okay, kiamat akan berlaku. Okay, so this is I think it's an evidence, scientifically proven, that we are living in the final years of our own human civilizations. But we need to survive. Okay, we need to think how to survive, on how to secure the food, especially. Okay, perhaps this is a last month's newspaper cutting from the New York Times, that we need to learn from other countries like Singapore how to revitalize their our means that Malaysian agriculture sector. Okay, we need to learn from others. Perhaps we need to learn from Indonesia. Okay, because as I mentioned, we are moving away from agriculture since 1985. But we know currently that it's not an appropriate action before this, as we are leaving the agriculture sector. Okay. So another newspaper cutting about AI, artificial intelligence technology, can be a game changer in our palm oil industry. And some facts during the pandemic of COVID-19. Okay, we are talking about the food insecurity. Okay, not only in our developed countries, but also in the developing countries, in the third world countries. Okay, so I think that every countries have been negatively impacted okay, by this pandemic COVID-19, and especially for the food insecurity. So then we are looking at the second topic on the food security, as I mentioned, as I'm trying to give this overview, a big overview of what happened to what is happening currently in our world, not only in Malaysia but in other places. Okay, we are talking about the food security and another one in our food safety. Okay, in terms of a food security, these are some of the points under the food security, on the food utilization, on the food access, and also on the food availability. And then in the food safety, we're talking about raw materials, the pathogen, the processing, and also the cross contamination, and so on and so forth. Okay, I'm coming from the International Institute of Halal Research and Training. Before this, I'm attached to this institute, or INHAT, International Institute for Halal Research and Training, and so most of our research and also most of our consultancy projects are mostly related to the food safety, but not very much about the food security. But inshallah, afterwards, I will share with you the one of our latest project that related to the food security, that we think that it is an appropriate time for us to move forward on these issues on the food security. Okay, so what is the food security? As mentioned by the FAO, the Food Agriculture Organization, that it exists when all people at all times have physical, social, and economic access to sufficient, safe, and nutritious food, which meets their dietary needs and food preferences for an active and healthy life. Household food security is the application of this concept to the family level, with individuals within household as the focus of concern. Okay, so then inshallah, we look at the agricultural revolution. Perhaps our previous speaker, our prof, has mentioned about this IR 4.0, Industrial Revolution 4.0, and how it relates back to the agricultural revolutions. So we know that it started with the first industrial revolution, second industrial revolution on the advances of telecommunication and electricity. Okay, and then the third revolution on the digital revolution. Okay, and especially on the food or agricultural industry, we are talking about using some of these latest technology, like high yielding varieties, insect and weed resistant crops, and so on and so forth. And also the availability of satellite technology, which enable farmers to increase their produce, okay, and also to record their production, analyze the data, and perhaps they can do a good decision, okay, in order either to continue or to stop the activities. Okay, and then the latest revolution, we are living in this era, the fourth industrial revolution, IR 4.0. Okay, and we are talking about the offering digital information. Okay, as our prof mentioned about this cloud manufacturing. Okay, and the industries will becoming more smarter, more efficient, more safer, and more, the most important thing is on the environmentally sustainable. Okay, as perhaps our moderator just introduced me, I'm more on the carbon management. We are talking about on how to reduce carbon emission, especially at the manufacturing industry, the construction industry, the buildings, the office building, and so on and so forth. So we have some tools that we have developed on how to manage especially the carbon emission related to this. So perhaps that afterwards, maybe in future we can combine these two knowledge from the carbon management knowledge with the manufacturing knowledge, okay, in terms of to provide this environmentally sustainable industry. Okay, and also we are talking about also in the fourth industrial revolution on the smart farm, okay, which perhaps to adapt this autonomously and the real-time technology. Okay, so the agriculture 4.0, as I mentioned, is also need to be green, with science and technology at its heart. It's a combination of science and science technology with the skills of a farmer, perhaps. Okay. First thing first, I think just to look back on the what you call this the concept of a supply chain, okay, from farm to fork, from the agriculture to the consumer, to the fork, okay, to the table. And this during the agriculture, during this level, we are talking about the production of food, the production of plant, okay, the production of perhaps paddy, ataupun some of the vegetables. And also during the agro industry, we're talking about the processing, okay, the processing of the products through this industry, or to this what you call this factories, okay. And then the product will need to be distributed to the consumer. Okay, so perhaps these are some of the basic. I believe that most of you, I think all of you are in this industry, and this is, I think, the fundamental of the agro industry and agriculture industry areas of knowledge. Okay, so what is agriculture 4.0? As I mentioned, we are talking about the usage of technology, not only the machineries, but also the softwares, the platform, okay, the IT-based technologies. Okay, for example, like the Internet of Things, IoT, the sensing technologies, because it's about data. It's about data on how we can import the data, ataupun we can capture the data. Okay, we can capture the data through some of these softwares or platform, and then we can analyze it. We need to analyze the data to be the information. Okay, we are talking about big data. We are talking about the physical technology like robotics, the automated equipment, and also the satellite image and positioning. Okay, if we compare it to a small scale farm where perhaps there is no digitalization, is an analog, no sensing available, no data or records, manual labor, and hand or animal power and farmer experience. Okay, so these are some of these. I think Prof also mentioned about the cloud manufacturing related to this system. Okay, from the product to the interrelation between the system of systems, like for example, like the weather data system, the seed optimization system, the irrigation system, and also the farm equipment system, which the physical equipment or technology like this tractor will be using the sensor to connect to the internet, okay, to the cloud, cloud manufacturing or the cloud computing. It will be a smart connected product, and then it will be go stream to the whole of system, as I mentioned. Okay, so this is a step of crop to the actuation. Okay, the platform data and precision. I just skip all this. I think I have only another 5 minutes, I believe. Okay, so these are the detail of IoT, the big data, the cloud computing, the push and pull factor. I just skip all this, Brother Rizky, Mr. Rizky, because due to I believe we have another speaker afterwards, isn't it? Okay, okay, just to share what we have currently. Okay, this is some of the technology that I believe that everyone has the opportunity to read by yourself through the internet and also the e-magazine and so on, from journals. Okay, this some of the physical technology like robotic, okay, agrobot in the case of this for the agriculture, okay, the drone technology for information, perhaps also in Indonesia you are using this drone technology in some of your agriculture sector. In Malaysia we are using it, okay, in paddy field, in some of our area in northern part of peninsula, okay, especially for the crop spraying, crop monitoring, and so on. Okay, and then these are the usage of satellite data, okay, and also the future smart farming. Okay, I just keep all these. Okay, just like to share with you the perhaps the two case study or two projects that we're currently doing. One we call as a SCS fatigue. This is a research to come up with a whole system in order for us to come up with a smart agriculture farm where we have four technologies. Okay, the first one on the smart farm technology about sensor to get all this data from energy and water, and in order for us to come up with the energy and water efficient equipment to be used on the in this and then the composting technology on the waste management, the IoT used to monitor all equipments like crop production and marketing, and also the carbon footprint. And the most important thing that is we are using this blockchain technology used for verification, especially for the halal products. So we like to connect this farm, okay, from the farm to fork in terms of providing a verification by using the blockchain technology in order to ensure that our food is halal and tayyib. Okay, it's a halal production without any cross contamination from others material. So one of a big, I think, a crucial thing in this research on to provide this blockchain technology. Okay, and also we are trying to incorporate this tourism industry together with the farm. Okay, in our farm with this providing this homestay, Muslim friendly homestay. Okay, where we have our own rating system for homestay in order to be certified as a Muslim friendly homestay. Okay, and at the end, this is the last technology that we like to incorporate is on the apps. Okay, connecting all these number one, number two, and number three into one apps, mobile apps. Okay, connecting this smart file with world halal industry business opportunities, and also to connect this Muslim friendly homestay with the Muslim friendly tourism ecosystem industry. Okay, and another the second project that currently we are doing is we call it as a certified toy food outlet. This is at the end of the for this these are the fork, okay, at the table, okay, of the consumer. Okay, we are talking about to provide a good, healthy, halal, and tayyib food. Okay, and also we need to ensure our food outlets, the food vendors are being audited and certified accordingly to our this rating system. Okay, we're talking about this premise, nutrition menu, food hygiene, food safety, employee food service, and innovation. And the part for the part of digitalization also we put is under innovation, and on the food security we put under this not only the food safety but some of this nutritious menu and also the under innovation points. So these are our latest products that we have come up under our research groups, and currently our aim for this year is to audit and certify at least 50% of our food outlets in our university in the International Islamic University Malaysia in Kuala Lumpur. Okay, I think that's it for me. Thank you very much. I'm sorry because I think, as I mentioned, I'm not quite strong to continue the speech. Perhaps after this, I need to have a rest. Okay, back to you, Mr. Rizky.
Thank you very much, Dr. Syakrin. Firstly, we hope your conditions recovers well, quick, and you and your family are all fine. So please have a rest after this, Dr. Syakrin. So thank you very much, Dr. Syakrin, for the very interesting topics. So we will now have our fourth and last speaker before we get into the question session. And once again, we would like to remind all the participants, if you would like to ask any questions, please type it in the chat box, or you can use your microphone and speak through your microphone during the Q&A sessions. Thank you. And also, attendance form will be available during the second question sessions. Oh, there it is. The committee has shared the attendance form. You can fill the attendance form. Thank you. So, right now we get into the fourth and our last speakers for today. Our fourth speaker is Mr. Christian Dwi Kusuma, SPSI. Mr. Christian is a human resources consultant and practitioner, and also trainer and motivator and coach as well. And Mr. Christian is a training manager at Mayura Group Beverages Division. He has vast experiences as psychology consultant involving students, teachers, parents, and I believe any other people. And also Mr. Christian has vast experiences in human resources development, such as employee competence, needs identifications, curriculum competency development, and also trainings. And today, Mr. Christian will deliver a talk of transformation and digitalization in agroindustry. So the time is about 20 to 25 minutes. Mr. Christian, the time is yours. Thank you very much.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Mr. Rizky. And thank you for invite me in webinar ya, Ibu Sri Hartati gitu ya. I want permission about my speech with bahasa, okay? Okay. I will speak in bahasa, okay. Oke, tadi sudah banyak dikenalkan ya dari macam-macam ini ya, dari Bapak dosen-dosen luar biasa sekali gitu ya, berkaitan dengan ini ya, apa yang sudah disampaikan terkait bagaimana sih industri 4.0, kemudian bagaimana crowd manufacturing dan sebagainya gitu ya. Sebenarnya kami pun akan menyampaikan juga apa yang menjadi concern kami dan apa yang saat ini ya kita kembangkan ya, apalagi berkaitan dengan ini ya, berkaitan dengan agroindustri itu sendiri seperti itu. Nah, sebelumnya gitu ya, tadi sudah seperti dikenalkan ya. Jadi sehari-hari gitu ya, kalau saya sehari-hari di Mayura Group sebagai ini ya, technical training manager atau sebagai ini ya, koordinator untuk training di beverage division. Jadi kalau singkatnya berkaitan dengan pekerjaan apa yang saya lakukan, yang pertama berkaitan dengan mengkoordinasikan kegiatan ini ya, pengembangan learning and development all beverage division, kemudian berkaitan dengan desain kurikulum, dan yang terakhir adalah berkaitan dengan training as a trainer seperti itu. Baik, saya kenalkan dulu atau will introduce about M3 ya. In Mayura atau di Mayura sendiri gitu ya, ada dibagi menjadi beberapa grup ya. Grup pertama itu adalah berkaitan dengan biskuit atau makanan gitu ya, biskuit, coklat gitu ya. Kemudian biskuit yang grup yang kedua atau M2, dikenalnya ada M2. M2 itu berkaitan dengan kopi, pengolahan berkaitan dengan kopi. Dan yang ketiga, nah yang ketiga ini adalah berkaitan dengan apa? Beverage division atau lebih tepatnya adalah ready to drink, atau lebih banyak lagi disebutnya adalah pabrik minumannya. Nah, untuk saat ini sendiri gitu ya, untuk pabrik minumannya itu ada kurang lebih 8 factory di mana letaknya ada di Jawa Barat, kemudian Palembang, Makassar, dan Jawa Timur, seperti itu. Ini berkaitan dengan pabrik-pabrik dari Mayora Group sendiri. Makanya kenapa yang namanya pabrik Mayora Group kan beda-beda ya, berkaitan dengan PT-nya. PT-nya mulai dari pertama yang mungkin lebih dikenal adalah Mayora Indah gitu ya, tapi ada beberapa PT lagi. Misalkan Deli Food Sentosa Korpindo, kemudian ada yang namanya Kakao Mas Gemilang, pengolahan coklat, kemudian ada yang pengolahan terkait kopi, itu adalah namanya Torabika Eka Semesta, dan kami sendiri yang berkaitan berhubungan erat dengan air, itu namanya adalah PT Tirta Fresindo Jaya. Nah, apa yang dikelola di PT Tirta Fresindo Jaya atau apa yang diproduksi di PT Tirta Fresindo Jaya berkaitan dengan ini ya. Nah, ini adalah produk-produknya, maaf. Nah, ini adalah produk-produknya teman-teman ya, Bapak Ibu. Produk-produknya mulai dari mineral, teh pucuk harum, kopi cool 78, kemudian cool time, kopi cup, guava, and 7 kurma. Jadi ini sekilas ya, apa saja yang kami kelola. Jadi bahan baku utama kami adalah air. Nah, kemudian kalau yang lain selain itu ada teh, kemudian ada langsung dari kelapanya langsung, kemudian ada yang namanya kopi. Kopi kita ngambil langsung dari PT Torabika Eka Semesta. Dan kemudian ada guava atau jus jambu, dan yang terakhir adalah berkaitan dengan 7 kurma. Nah, selama pandemi ini kami pun juga ini ya mengalami transisi dalam artian ada perubahan inovasi. Inovasinya salah satunya adalah kami juga merambah ke salah satu produk yaitu namanya home care. Home care ini mungkin Bapak Ibu atau teman-teman sekalian mengenalnya adalah salah satu produknya adalah berkaitan dengan apa? Gentle Gen atau sabun cuci cair. Ini adalah salah satu produk-produk yang kami kembangkan ini ya, inovasi di masa pandemi. Jadi ada kebutuhan sanitasi, jadi kami kembali lagi kebutuhan sanitasi inilah yang kita jawab dengan apa? Salah satunya dengan home care. Bukan personal care ya, bukan personal care tapi lebih pada home care. Berkaitan dengan ini ya, berkaitan dengan produk Gentle Gen seperti itu. Oke. This is quality and food safety policy. Jadi berkaitan dengan ketentuan undang-undang yang kami ikuti gitu ya, baik berkaitan dengan food safety FSSC ya, food safety system certification, kemudian SNI, kemudian ada lagi namanya ini ya berkaitan dengan halal juga kita ikuti seperti itu. Jadi beberapa ketentuan-ketentuan yang mengacu pada prosedur polisinya. Oke. Baik, saya akan coba sampaikan gitu ya berkaitan dengan apa sih yang ini ya. Bagaimana aplikasi dari 4.0 sendiri, kemudian bagaimana aplikasi dari cloud manufacturing itu sendiri. Saya akan coba jelaskan lewat video ini. Oke, itu yang sudah bisa saya sampaikan sedikit bagaimana pengaplikasian terkait ini ya, industri dan transformasi dari industri ini ya, industri yang sifatnya konvensional menuju industri 4.0. Dan salah satunya lagi bentuk pengaplikasian dari manufaktur sendiri berkaitan cloud sendiri, itu ada beberapa hal yang akan saya tekankan. Yang pertama, kalau yang bicaranya hanya bicara ini ya, raw material itu kita kelola langsung ya, mulai dari kelapa gitu ya, sudah bayar menggunakan apa yang namanya mesin atau namanya teknologi. Kemudian yang kedua, tentunya kami juga tidak akan lepas dari apa yang namanya ini ya, kontaminan. Kontaminan ini sendiri kami coba kendalikan atau paling tidak kita coba minimalisir agar kita tidak menggunakan bahan pengawet. Salah satunya adalah bahan kemasan. Bahan kemasan sendiri itu kita langsung produksi di sini. Mulai dari botol, tutup, itu kita langsung produksi di pabrik sendiri. Nah, ini tadi saya coba contohkan adalah salah satu pabrik kami yang ada di wilayah Jawa Timur atau di wilayah Pasuruan. Nah, untuk beberapa pabrik-pabrik lainnya gitu ya, hampir sama semua ya, semuanya langsung ya. Kalau kita bicara mengenai bahan produksinya sendiri atau raw material sendiri itu kami peroleh langsung dari beberapa supplier. Kemudian kalau kita berkaitan dengan selain supplier, kami juga berkoordinasi juga dengan M lainnya. Salah satunya adalah M2 atau Torabika Eka Semesta berkaitan dengan bahan baku kopinya seperti itu. Nah, apalagi yang berkaitan dengan ini ya, berkaitan dengan pengolahan packaging material, pastinya tidak akan lepas dari dua hal, mekanik dan elektroniknya. Kalau kita bicara mekanik atau mekatronik ya lebih tepatnya kalau berkaitan dengan mekatronik itu sendiri, kami lebih banyak berkecimpung di dunia packagingnya atau di proses pembuatan botol, tutup, kemudian proses pembuatan galon, pembuatan gelasnya kopi cup. Nah, kalau kita bicara lagi berkaitan dengan production process, ini juga tidak lepas dari juga sama apa yang namanya ini ya, pengaplikasian sensor, kemudian pengaplikasian dari human machine interface. Dari sana kita bisa tahu bagaimana data itu kita peroleh ya, data bagaimana proses pengendalian dari OPRP, dari proses pengendalian dari PRP maupun pengendalian dari CCP itu sendiri. Ini kalau kita bicara mengenai bagaimana sih di pemanfaatan teknologi di area production process. Nah, ini juga akan lepas juga dengan apa yang namanya proses pengendalian. Pengendalian ini ada dua macam, ada berkaitan pengendalian pada saat working in process atau pengendalian pada saat menjadi finished good atau produk itu sudah menjadi dari finished good itu sendiri seperti itu. Jadi kalau bicara mengenai bagaimana sih pengaplikasian dari teknologi-teknologi yang ada. Nah, yang terakhir tentunya tidak lepas juga berkaitan dengan apa yang namanya proses dari warehouse system sendiri seperti itu. Nah, di warehouse pun juga melakukan pengendalian baik itu terhadap produk yang sudah sifatnya inkubasi, sifatnya retain, sifatnya apa yang namanya siap didistribusikan ke pasar. Ini salah satu pemanfaatan teknologi yang ada di lingkup dari Mayora Group sendiri. Jadi banyak hal yang bisa ini ya dikembangkan dari apalagi kalau kita bicara mengenai 4.0 sendiri ya, bagaimana menggabungkan ini ya sisi mekanik, sisi elektrik, kemudian sisi dari data itu sendiri gitu ya. Apa yang kami lakukan, apa yang kami gunakan berkaitan dengan pengembangan dari digitalisasi itu sendiri. Nah, kalau kita bicara pengembangan dari saat ini gitu ya, kalau kita bicara mengenai pengembangan dari teknologi itu sendiri, bukan hanya sifatnya kalau yang lalu gitu ya, lalu itu mesin hanya bisa memproduksi satu mesin, itu bisa memproduksi satu produk saja atau satu merek saja. Nah, kalau untuk saat ini gitu ya, kalau bicara mengenai perkembangan dari teknologi sendiri, satu mesin itu bisa menghasilkan minimal 2 produk atau paling tidak bisa menghasilkan sampai dengan 7 produk. Artinya ada yang namanya sistem change over. Change over ini membantu memperbesar kapasitas, kemudian memperbesar bagaimana varian dari SKU atau varian dari unit produksi yang ada di masing-masing ini ya plant seperti itu. Nah, bagaimana pemanfaatan dari ini sendiri ya, bicara mengenai cloud ya, atau bicara mengenai big data itu sendiri. Nah, kalau kita bicara mengenai pemanfaatan dari big data itu sendiri, yang pasti yang pertama kita bicara mengenai coding. Nah, saat ini kan aplikasi dari masing-masing ini ya, masing-masing mesin berkaitan dengan 4.0, berkaitan dengan data itu sendiri adalah berkaitan dengan masalah coding. Coding ini memberikan sinyal sinyal kepada kami bahwasanya ada beberapa hal gitu ya yang perlu misalkan diimprove. Ini kalau kita bicara mengenai real time berkenaan dengan kondisi saat ini. Berkenaan kondisi saat ini, data-data berkaitan dengan coding ini tentunya sudah tidak asing lagi bagi ini ya, bagi karyawan kami harus membaca coding berkaitan dengan penerapan dari industri 4.0 sendiri seperti itu. Nah, berkaitan dengan data ini ya, cold manufacturing sendiri berkaitan dengan penyimpanan data itu sendiri, apa yang bisa kami manfaatkan? Salah satunya bicara mengenai apa? Data for preventive maintenance atau data for improvement. Karena ada beberapa ini ya, ada beberapa kejadian yang mungkin tidak bisa ditangkap oleh beberapa karyawan. Namun dari data yang dikirimkan dari sensor itu sendiri yang kita simpan dalam cloud tadi, itu bisa memberikan kira-kira apa yang harus kita improve, apa yang harus kita lakukan berkaitan dengan apa? Preventive maintenance sendiri. Itu yang berkaitan dengan pengaplikasian dari ini ya, 4.0 itu sendiri seperti itu. Ini berkaitan dengan apa saja sih, bagaimana sih kami mengimplementasikan dari sistem teknologi and digitalization. Kalau kita bicara teknologi, semakin ke sini akhirnya apa yang kita produksi semakin lebih banyak variannya atau lebih banyak ini ya, bicara mengenai ini ya, mulai dari air mineral itu sendiri, kemudian satu produk bisa menghasilkan lebih dari satu mesin bisa menghasilkan lebih dari 7 produk itu sendiri. Nah, kalau kita bicara mengenai digitalisasi, nah digitalisasi ini sangat membantu di kami. Artinya kami sudah terbiasa dengan IoT. Jadi kami punya ini yang namanya komputer server, di mana komputer server ini yang mengendalikan data ini berkaitan dengan preventive for maintenance atau berkaitan dengan bicara mengenai apa? Improvement berkaitan dengan ragam ragam produk yang kita kelola. Produk yang kita kelola itu baik itu yang sifatnya raw material, baik itu yang kemudian yang sifatnya apa? Packaging material. Ya, kalau kita bicara mengenai raw material, jelas mulai dari bagaimana cara pengolahan bahan teh, gula, kopi dan sebagainya. Kalau kita bicara mengenai pengelolaan berkenaan dengan packaging material, tentunya ada dua ragam packaging material, baik itu yang sifatnya primer maupun yang sifatnya sekunder. Kalau kita bicara primer berarti jelas berkaitan dengan botol, tutup, kemudian berkaitan dengan gelas, galon, ya. Kemudian yang terakhir berkaitan dengan data sekunder adalah berkaitan dengan masalah masalah berkaitan dengan masalah labelnya, label atau karton itu sendiri. Nah, pengembangan saat ini bukan hanya kita bicara mengenai ini ya, teknologi dan digitalisasi. Nah, kami sebagai produsen itu juga memiliki kewajiban ya. Salah satu kewajibannya adalah berkaitan dengan ini ya. Baik lagi dengan waste management atau berkaitan dengan berkaitan dengan bagaimana kita melakukan efisiensi dan conservation. Nah, ini yang akan saya bahas berikutnya. Jadi agroindustri itu untuk saat ini benar-benar lagi diminta atau kita menjalankan apa yang namanya fungsinya adalah mengembalikan lagi apa yang menjadi bahan baku utama kami. Salah satunya adalah penanaman pohon. Di mana yang dari tahun 2015 hingga 2021 kami sudah menanamkan pohon kurang lebih 61.000 pohon, dan ini terus berkelanjutan karena kami kembali lagi kewajiban kami ya kembalikan lagi apa yang menjadi sumber daya utama kami seperti itu adalah bicara mengenai air itu sendiri. Oke. Masih hubungannya dengan konservasi dan efisiensi gitu ya. Pastinya di kami pun juga memanfaatkan apa saja yang bisa kami manfaatkan dalam artian supaya sumber-sumber air, kemudian air-air yang masih bisa kita kelola kembali. Salah satunya dengan sumber resapan dan WTP recycle atau water treatment process yang berhubungan dengan apa? Dengan recycle itu sendiri. Ini tidak digunakan untuk minum ya. Ini not for drink, tapi ini langsung bicara mengenai digunakan untuk katalis dalam apa? Dalam boiler itu sendiri seperti itu. Oke. Nah, pastinya kalau berhubungan dengan program dari reduce, reuse, recycle maupun recovery, ini adalah salah satu menjadi konsep utama di agroindustri saat ini. Di mana kami melakukan reduce berkaitan dengan budaya hemat energi, penggunaan motion sensor, lampu LED, kemudian skylight, glass box, dan timer PJO. Dan yang kami kembangkan saat ini beberapa plan kami yang baru itu juga akan mengembangkan apa yang namanya panel surya. Artinya energi yang kita gunakan bukan langsung dari listrik PLN, namun kita menggunakan teknologi dari panel surya itu sendiri. Kemudian berkaitan dengan reuse, ya, masih penggunaan ini ya, berkaitan dengan kertas bekas, kemudian eks pembungkus dari work in prosesnya cap maupun preform kita gunakan kembali. Tapi juga ada yang namanya proses pengendalian berkaitan dengan mungkin adalah cross contamination for ini ya, dari plastik atau dari cover yang ada di kontainer itu sendiri. Nah, air yang habis kita kelola pun itu kita gunakan kembali. Salah satunya adalah penggunaan untuk toilet maupun taman. Jadi bagaimana kami memproses ini ya, air itu benar-benar jangan sampai dalam artian dibuang percuma seperti itu atau hanya mengalir ke saluran air saja. Dan berkaitan dengan recycle, pastinya ini kan menjadi konsen utama kami gitu ya, di mana proses penggunaan bahan ini ya, packaging material. Nah, ini kita mencoba menggunakan material regrade. Dan bahkan kami sedang mengembangkan nih, kalau kita bicara mengenai bagaimana pengembangan teknologi, salah satunya adalah kami sedang mengembangkan juga bagaimana resin yang ini ya, yang kita hasilkan atau dalam artian sudah menjadi botol tapi tidak dipakai lagi atau sudah menjadi sampah. Ini kita coba rubah menjadi minyak. Salah satunya yang kita kembangkan saat ini adalah berkaitan dengan minyak ini untuk untuk mesin pemotong rumput atau bahkan untuk campuran dari mesin ini ya. Beberapa kendaraan yang memang kendaraan kami yang menggunakan masih berhubungan dengan bahan bakar fosil. Salah satunya penggantinya adalah berkaitan dengan penggunaan dari resin itu sendiri. Dan yang terakhir, kalau berkaitan dengan 4R atau berkaitan dengan pemanfaatan yang menjadi ini ya, kita kembangkan berkaitan dengan teknologi, lagi ada berkaitan dengan kegiatan recovery. Artinya kita mengkonversi energi yang ada itu masih menjadi sumber daya biologis. Salah satunya penggunaan economizer gas, buang boiler, kembalikan lagi untuk menjadi pemanasnya kembali. Ini yang berkaitan dengan ini ya, bagaimana kami mengembangkan teknologi dan kami mengembangkan yang namanya ini dari IoT itu sendiri. Ini beberapa penghargaan yang kami miliki ya, berkaitan dengan ini ya, support berkaitan dengan regulasi-regulasi yang ada. Dan yang terakhir ini adalah yang menjadi konsen saat ini beberapa perusahaan yang ada di Indonesia adalah berkaitan dengan masalah industri hijau. Salah satunya bagaimana kita mensiasati perubahan iklim agar kita tidak memberikan sumbangsi yang cukup besar terhadap perubahan iklim. Salah satunya dengan industri hijau. Mungkin itu yang bisa saya sharingkan atau ini ya saya presentasikan berkaitan dengan teknologi dan digitalisasi dan apa yang menjadi konsentrasi kami di kegiatan improvement dari industri itu sendiri. Thank you, Mr. Rizky.
Right, thank you very much, Mr. Christian, for the very interesting and useful presentations of topics. So thank you also for both of the speakers in this second session. Now we straight get into the questions sessions. It's about 15 minutes. We already have only from one participant, but it has 3 questions. So I think it's Miss or Mrs. Margaret. Question number 1 is it's for Dr. Shakirin or Mr. Christian. So in the first one, what is the position and potential of SMEs in the era of Industry 4.0? Do SMEs have a chance, and are SMEs capable to keep up with the Industrial Revolution 4.0? Maybe Dr. Shakirin, do you have any answers on comments on these questions?
Okay, thank you. Thank you, Mr. Rizky. And the question, Ms. Margaret, about this. What is the potential? Okay, we know that the SME, small manufacturing enterprise, or sometimes we are looking at micro also. So most of them having problem with funding issues, isn't it? funding, because when we talk about on how to for them to change the process, perhaps for example, that they want to embed with the technologies, and we know that some of the technologies incurred some high cost to get. Okay, for example, like robotic. We are talking robotic. We are talking about drones. So these are some of the high technology that needs funding, need high cost. So what happened in I give an example in Malaysia, that what we try to do is that we try to subsidize some of these technologies to be used by our own SMEs, okay, under relevant agencies, okay, until perhaps they are ready by themselves to to get their own technologies, when perhaps afterwards they have a huge profit, and then they know the advantage of this embedding all these technologies in their process. So the ball will roll by itself, perhaps inshallah afterwards. Okay, I think for the first question, I think it's more on the, as I mentioned, more on the funding issues. Okay, and also I believe that I can answer question number 2 also, the how we can be able to join in the industry 4.0 by like I said that in Malaysia we subsidize some of our technologies to our farmers or to our SMEs. Okay, and also another example is also we have our own for halal industry, we we have this halal park, or halal hub. Halal park or halal hub is where the government set up this area, and they provide all these facilities, which include the buildings, the infrastructures, and some of it by providing some basic technologies. So that is another example of how we subsidize these SMEs until they are ready by themselves to adapt the technologies later on. Okay, I think that's all from me.
Thank you, Dr. Syagrin. Mr. Christian, perhaps do you have any additional answers or comments on this about the positions, potential of SMEs, their capabilities to keep up with industrial 4.0 maybe?
Oke, salah satu yang bisa saat ini yang bisa menggerakkan UKM itu sendiri adalah ini ya, kebetulan untuk yang pengaplikasian saat ini adalah regulasi dari pemerintah itu sendiri. Di mana kami diminta untuk melibatkan apa yang namanya UKM. Sebelum kita membesar kapasitas, salah satu yang kami lakukan adalah salah satu syarat yang dipersyaratkan oleh pemerintah saat ini adalah melibatkan UKM. Nah, apa saja yang sudah kami libatkan berkaitan dengan UKM itu sendiri ya di era industri 4.0, salah satunya adalah kegiatan-kegiatan yang sifatnya mungkin salah satunya adalah berkaitan dengan fabrikasi fabrikasi baik itu mekanik maupun elektrik. Untuk saat ini gitu ya, UKM Indonesia itu mampu berkaitan dan bersaing dengan beberapa mesin maker yang ada di luar negeri. Ya, salah satunya adalah kami tentunya ada beberapa pembatasan spare part yang datang dari luar negeri ke Indonesia, atau itu kan butuh waktu atau waktunya itu luar biasa sekali. Nah, inilah kami diminta untuk melibatkan UKM salah satunya. Fabrikasi spare part itu sudah melibatkan UKM. Kemudian apakah UKM lain apakah tidak terlibat? Salah satunya ada yang lain terlibat. Salah satunya berkaitan dengan catering. Berkaitan dengan industri catering itu sendiri, kami melibatkan banyak dari UKM. Jadi bukan lagi kita jadi bukan tidak ada peluang, ada malah justru banyak peluangnya. Banyak peluangnya. Bagaimana UKM itu sendiri memperbesar kapasitasnya dengan cara apa? Ya mungkin kalau saat ini ya pemerintah Indonesia lebih melonggarkan ya berhubungan dengan regulasi-regulasi yang ada, terutama untuk yang UKM. Dan kami pun gitu ya, ketika bicara mengenai pengembangan kapasitas produksi kami gitu ya, kami harus diminta untuk melibatkan UKM yang sudah memang terdaftar Salah satunya di BKPM. Itu salah satu yang ini ya pernah saya ketahui berkaitan dengan ini ya. Bagaimana sih UKM itu dilibatkan? Nah, jadi no problem. Bahkan UKM itu dilindungi untuk saat ini di pemerintahan Indonesia, di mana memang benar-benar dilibatkan ya, baik itu di industri yang skala kecil maupun skala besar. Itu. Thank you.
Thank you, Mr. Christian. If I may ask a follow-up question, Mr. Christian, and if it's allowed for you to answer, can you give a specific example of what is the SMEs? I mean, UKM apa Pak spesifiknya yang dilibatkan? Apakah UKM produk apa atau yang apa di mana begitu? Barangkali ada contohnya.
Yang lebih spesifik berkaitan dengan ini, kalau UKM catering kita masih wilayah, kalau misalnya Pasuruan ya di wilayah Pasuruan itu sendiri. Jadi atau paling tidak gitu ya, di dekatnya pabrik itu misalkan nih ada kelompok usaha. Salah satunya adalah Karang Taruna. Indonesia terkenal dengan Karang Taruna itu sendiri. Nah, kami melibatkan ini teman-teman dari Karang Taruna sendiri untuk membuat salah satunya adalah bentuk UKM. UKM yang apa yang kita libatkan, salah satunya kalau misalkan di wilayah dekat pabrik dan lebih banyak ibu-ibu, itu lebih banyak adalah catering, berhubungan dengan catering. Nah, kalau berkaitan dengan lainnya UKM yang terlibat adalah ini ya, berhubungan dengan ini pabrik-pabrik spare part. Proses pembuatan spindle-nya, kemudian proses pembuatan pembuatan nozzle-nya gitu ya. Jadi ada beberapa ini ya, beberapa yang memang tidak kita tunggu dari luar negeri tidak datang-datang karena prosesnya kan ini ya menunggu sangat lama atau butuh waktu gitu ya. Nah, dari kita melibatkan langsung spesifik di daerah, kalau yang di Pasuruan sendiri itu di daerah Pandaan. Pandaan banyak melibatkan ini ya fabrikasi berkaitan dengan part-part yang kita butuhkan berkaitan dengan plate heat exchanger gitu ya, kemudian berkaitan dengan spindle, kemudian atau berkaitan dengan sensor pun orang di Indonesia pun juga mampu, atau UKM Indonesia juga mampu berkaitan dengan ini ya, menyediakan fabrikasi dari sensor itu sendiri seperti itu.
Thank you very much, Mr. Christian. And another questions from Margaret is maybe we go to Dr. Sagrin first. So, Dr. Sagrin, what do you think? What are the research opportunities with the SMEs related to digital transformation? So, perhaps maybe there are lecturers or researchers or students who are interested in this kind of research. Maybe you have any suggestions? What are the research opportunities, Dr. Sagrin? Thank you.
Okay, thank you. Perhaps some of the research opportunities related to this SME to transform themselves to be a digital citizen is perhaps the study on the readiness. So I think that's the fundamental part of it. The readiness of the SMEs. We need to know how ready they are with this transformation. Okay, and then perhaps afterwards, after we know the readiness, then perhaps the awareness. Okay, maybe number one, awareness, and then readiness, and then the third one is the how they can implement it. Okay, they implement the transformation of themselves in terms of digitalizations. Okay, another research perhaps on the system, like what we are currently doing. If I show you the example of our research is on the technology itself in a small scale, that in relation, and also in order to come up with that, also we need to know the current situation of products, okay, or the industry itself. Okay, I give an example of what we are doing right now for TFOS, the Toy Food Outlet Rating System. Okay, even though it's not related directly to digitalization, but another concern that we are looking at is on the food, healthy food provided. Okay, healthy food provided to the end customer. Okay, how we can what call that, this sorry, I just lost my words. What I call that, how we can ensure that the food being provided to us is a very healthy food, is organic food. Okay, so on this matter, even though it's a different discussion on the food safety, on the food nutritious food, the healthy food with the digitalization, but I believe also how a good research also need to be done on how to collaborate these few other factors. Okay, digitalization is not only data on the ground on the farm, but digitalization also we need to get data from the end products for the end customer, what they need, what they want, okay, what they want, and how we can provide them with a proper a good choices of products. Okay, so I think that's some of research opportunities I think that we can further do or further explore on that matter. Okay, thank you.
Thank you, Dr. Zakrin. Pak Christian, sebelum ke pertanyaan tentang peluang penelitian, ada pertanyaan sedikit lanjutan dari Margaret. Apakah artinya UMKM belum bisa berdiri sendiri, Pak Christian, untuk maju di era digital transformation? Menurut Pak Christian, seperti apa?
Kalau dikatakan apakah ini ya titik tekannya lebih ke arah collaboration.
Oke.
Nah, collaboration. Kenapa ke arah collaboration? Kami pun membangun transformasi digital ini juga tidak mudah. Di mana awalnya beberapa pabrik kami itu memang yang ada di ini ya di lingkup Mayora Group itu sendiri gitu ya, terutama yang beverage ya, karena kita mendekati sumber air, kita dekat dengan ini ya, dengan warga, tidak berada di satu kawasan industri. Nah, awal mulanya ya pertama-tama yang dilakukan adalah berat pertama kali ya, di mana kami harus menyesuaikan baik itu dari segi sumber daya manusianya, kemudian baik itu dari segi sumber daya energinya dan sebagainya seperti itu. Makanya kenapa dikatakan bahwasanya apakah bisa UKM itu bisa berdiri sendiri? Bisa. Namun ya untuk saat ini ya prosesnya itu harus langkah demi langkah. Mayora bisa menjadi besar seperti ini berkaitan bicara mengenai transformasi digital ya awal mulanya ya kami juga merangkak ya ini pelan-pelan kolaborasi dengan beberapa ini ya, beberapa kita belajar. Misalkan kita belajar dari pabrik kami yang ada di Thailand. Kita belajar dari contoh di paling sederhana kalau kita bicara mengenai pandemi Covid kemarin 19, kita belajar juga dari prosedur-prosedur yang ada di mana di Cina. Kebetulan kami kan juga punya pabrik di Cina. Pabrik-pabrik di Cina ini kita adopt semua kebijakan-kebijakannya. Nah, disinilah ini ya titik tekannya adalah di mana perlunya kolaborasi, Bu Margaret. Jadi kolaborasi itu apa? Ini untuk belajar dan satu sisi ya kita kembangkannya tidak bisa langsung besar atau langsung tiba-tiba jadi tidak. Kami pun juga step by step bicara mengenai bagaimana kami dulunya tidak mengerti IoT itu seperti apa dan akhirnya kami mengerti IoT itu seperti apa dan dulunya gitu ya kita tidak paham gitu ya, tidak paham bagaimana namanya ini ya sistem remote dari Jerman, remote dari Italia ya berkaitan dengan mesin-mesin kami karena pandemi dipaksa gitu ya. Jadi UKM bisa, namun ya pada saat fase-fase awal ketika memang membangun apa yang namanya transformasi digital, pertama-tama ya pastinya dibutuhkan apa yang namanya kolaborasi. Artinya perlu ini ya berkolaborasi dengan berbagai macam pihak supaya apa? Mendapatkan pelajaran atau mendapatkan ya pengajaran-pengajaran berkaitan sharing-sharing berkaitan dengan apa yang namanya transformasi digital itu sendiri.
Terima kasih Pak Christian. Kemudian tentang peluang penelitian Pak Christian untuk UKM hubungannya dengan digital transformation, barangkali nanti ada dosen atau mahasiswa peneliti yang ingin penelitian, barangkali menurut Bapak peluang penelitiannya apa Pak Christian?
Peluang penelitian.
Kalau
bicara mengenai peluang penelitian berkaitan dengan ini ya, kami masih mengembangkan ini ya. Salah satunya adalah data di kami itu banyak sekali. Mulai data dari proses produksi itu sendiri, kemudian data dari apa yang namanya ragam. Dan di kami itu tidak single supplier, Pak Rizky.
Oke.
Nah, tidak single supplier dan di sini muncul sebuah peluang ya, di mana salah satunya adalah dengan ragam raw material, dengan ragam packaging material, ini kan memunculkan improvement apa seperti itu. Nah, ini bentuk bisa jadi menjadi PR buat rekan-rekan mahasiswa atau menjadi PR dari dosen-dosen yang ada di Universitas Brawijaya. Salah satunya adalah kita ini coba ini ya. Salah satunya tantangan kami ya tadi kita nggak bisa bergantung dengan satu supplier baik itu yang raw material maupun packaging material. Dan kalau kita bicara mengenai apa yang menjadi kebutuhan konsumen kan saat ini banyak. Mulai dari apa yang menjadi keinginan pasar ya dari produk itu sendiri. Ya. Salah satunya adalah kebutuhan akan hygiene, kebutuhan akan ini menjadi bentuk peluang dari rekan-rekan mahasiswa. Salah satunya berkaitan dengan data-data di kami itu sangat bisa dibantu kalau misalkan dari teman-teman Brawijaya atau teman-teman dari mahasiswa maupun dosen berkenan untuk berminat untuk ini ya penelitian di kami. Karena data ini kami masih kebingungan karena apa bicaranya berkaitan dengan transformasi digital, data yang ditampilkan di komputer cloud manufacturing itu sendiri banyak, mulai dari data per jam, data baik mekaniknya maupun elektriknya itu banyak. Nah ini bisa menjadi peluang penelitian dari teman-teman mahasiswa maupun dosen yang ada di Brawijaya.
Thank you very much, Mr. Christian. That's very interesting. Miss or Mrs. Margaret, is that fine? Is that enough or okay? I think that's fine. Thank you very much. I think there is still time for one question only, maybe from the participants. If you have any other questions, there is still time for one question. Or maybe not, I guess. Right, so I think there are no more questions from the participants. So thank you very much, Dr. Sakrin and Mr. Christians for the very interesting and useful presentations. And I think that wraps up our webinar today. I think there are certificates for Dr. Sakrin and Mr. Christian. Maybe I will handle it to the committee. So this is the, oh not yet, sorry about that. Yeah, so thank you very much, Dr. Sakrin, for your contributions and participation as a speaker for today's webinar. We hope you recover quick for your health and you are fine, and we hope to see you again soon. Thank you very much, Dr. Sakrin.
Thank you. Thank you.
Yeah. And the second one is for Mr. Christian. Also, thank you very much, Mr. Christian. Sehat-sehat, baik-baik sekeluarga. Semoga ketemu lagi, Pak Christian. Sehat selalu. Yeah. Thank you very much, Dr. Sakrin and Mr. Christian. So, I think that's all for our today's webinar. Thank you very much for all the 4 speakers. A very amazing, interesting, useful presentations for us. And thank you very much also for all participants for joining in. And me as a moderator, I am sorry, I apologize if I make any mistakes during moderating this webinar. And also thank you very much for the committee and the faculty and the university. And hope to see you soon. Thank you very much and have a good day. Thank you.
Recording stopped.
Thank you. Waalaikumsalam, Pak.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Assalamualaikum. Waalaikumsalam, Pak Christian.
Dr. Sakrin and Pak Christian.
Terima kasih Bu Sri.
Thank you for your participation.